Hi, I'm David I, and welcome to my DelphiCon 2021 multi-platform explorations using Delphi, FireMonkey, Feeds, REST, and more presentation. We're going to cover the demo scenarios, technologies, the platform's topics, take a look at the databases I'm going to be using, a couple INI files, and a bunch of demos. Again, I'm David I wrote my first program 52 years ago. It was a Fortran prime number generator application on an IBM 360 mainframe. I'm an Embarcadero MVP. These are my social accounts, and at the bottom is my blog URL. This whole presentation is based on some programming I've been doing for the last several months. Probably if you've heard the news and looked on the internet and so on, you know that there were a lot of forest fires this year in different parts of the world, and especially in California and Northwest the United States. This is a picture from my house looking at the sun coming up through the smoke-filled Rogue Valley. So that was the genesis of me wanting to figure out how can I keep track of the air quality that was going on where I was at any point in time or if I was at my house. Now, Oregon has, as many other states have, a dashboard where you can see the current air quality in different parts of the state. This is a screen grab from my iPhone of a particularly bad area of smoke here in Ashland and along the Rogue Valley. I then started exploring how I could get more information and detail about what was going on. And I found a manufacturer of air quality sensors, Purple Air, and they publish through a REST interface public information about what's happening in the air quality around that sensor over periods of time. On their website, there's a Purple Air map. Then I noticed that there was also the way to get a HTML widget and then finally to look at the data underneath through an API. And with that, I built my first tablet PC application. Using the browser, there's this Oregon Department of Environmental Quality website where you can find what's happening around your local area. Purple Air, again, has their own map, which allows you to look and zoom in on Purple Air sensors that people have installed. So what I did is I took their widget information and put it inside of an HTML local file. And my first application just had a browser in the FireMonkey application, and it loaded the local file to get the information for this specific sensor, which is very close to my house. So that was the first thing, was finding information, figuring out how I could start doing development, and then building more applications on top of that, leading to an iOS application and an Android application that I hope to finish and put into the Apple Store and into the Google Play Store. The technologies I use in all of these demos are Delphi 11, FireMonkey. Some of my applications display a chart of historic air quality over time, and I use T-chart for that. I'm also using the sensor manager and the T-location sensor component to get the location of where I am so I can find sensors that are around me. I store data about different sensors in an InterBase database. I use FireDAC, and I use IBLite so I can deploy those applications to an Android device, a Windows remote machine, my iPhone. Now I wanted to be able to understand and get sensors nearby, so I use the location sensor to get my location. And there are other ways to get the location, as there's different publicly available APIs for getting a location from an access point or a known IP address that's somewhere nearby. I also wanted to be able to get information about where these sensors are, their address, their city, their country. There are tens of thousands of these air quality sensors that are around the world. For that, I use Google Geocode API. And then I wanted to also understand the elevation of different positions so I could see if a sensor was getting higher altitude smoke or altitude that was similar to where my house is or maybe down below me in the valley. I wanted to use maps, so I supported Google Maps and OpenStreetMap. As I move along, I want to support lots of different air quality sensors. I've started using Purple Air REST interface API to get the sensors that are around me, and for that matter around the world. I support Win32 and Win64, macOS, iOS, and Android. I've got Linux on my feature set for the future. using FireMonkey for Linux. The topic areas I'm going to look at is things surrounding multi-platform development of a REST-based IBLite database and FireMonkey, to make sure that you understand some of the things you want to pay attention to when you're building your applications. I wanted to make sure I understood the application and platform information. I use mem INI file, and then making sure that I could understand and set up the code and the deployment settings to get the INI files, the database file, the icons, and other things onto each of the platforms in the right subfolders associated with deploying my application to more than just Windows. You can use the sensor manager. With Android, there's a little bit more you have to do in code and ask the user to give your application permission. So we'll take a look at that in the source code. One of the things I wanted to do was to make sure I could get news of what was happening in the wildfire areas and news areas surrounding where these sensors are. So I created a database that has an air quality news feed, and then use XML document to pull the information from the RSS feed, and then I'll support Atom in the future. Devices, I have another database, and then I have two INI files, one for my AQI-based applications, and then for the Google Cloud interface, I wanted to be able to provide separately the Google Cloud API key in an INI file. So I have two INI files. One is my AQI app. Here I have my favorite latitude and longitude. That's my home location. Some options in the mobile application for how many sensors to show at any one time, and how many miles to look for sensors in a radius of my current location. And I also have a favorite sensor. The INI file allows you to set up how often you're going to make a call to a selected sensor to get the particulate information, and then use a standard calculation for coming up with the AQI number. Second INI file is just my Google Cloud API keys. In IB Console, I have my two databases. I have the Air Quality Feeds database. It has one table called a feed list. It has only 4 columns. One is a varchar 100 for the feed name, the URL for the feed, the type of feed, and when that feed was last added and processed. Then if we look at the AQI database, it has 2 tables. One is the sensor devices table, and in there we have the name, the location, the latitude and longitude, the address, city, state, province, zip code, country, elevation, geocode, when that sensor was last seen, that's in Unix timestamp, and when there was the last updated. And then I run a periodic process to calculate the distance from my favorite location defined in the INI file. I also have a second table called sensor data that I may use over time, and all that's going to do is save a date, time, and this particulate matter 2.5, the AQI calculated what the temperature, pressure, and humidity are, that if I want to, I could start saving historic data. And now it's time to get to the demos. There are lots of different demos. I built a bigger application and then deconstructed it into individual parts just to make it easier to demonstrate the parts of the application. It all ends up ultimately with my app called AQ Insight, which runs on my iPhone right now. And again, we'll a little more cleanup, and it should appear at some point in time in the Apple App Store and the Google Play Store. Okay, I've got a project group. So this first one is so that I could put up an about box in my application about what platform it's running on and what the application version information is. You know, it's the usual thing that you want in an about box. With the help of a bunch of Stack Overflow searches and documentation, and I could figure out version information for each of different platforms. So first thing, this is a FireMonkey application. And then I have a couple of labels and a button click handler for getting the version information. I created a couple different form views, one for an iPhone, one for an Android tablet, and one just for Windows and macOS. I needed to put a few if defines to bring in uses for different platforms when I build the application. So if defined iOS, I've got to bring in these helper units. For OS X, I found out that if you are building an iOS application, that iOS and macOS are both defined. So the way that to differentiate, to bring in only the units and other parts of code for macOS is to use if defined OS X. So that case, I only needed to bring in the APIs for doing a macOS version of the application. And for Android, bringing in some helpers that are wrapping some Java code underneath. And for Windows, just using the Windows API. So, and then I provided two internal functions that I use for MS Windows. So ifdef MS Windows, gets the file version from the application that's launched, and then just returns the result as from the high and low byte of that record get file version returns, and then return that as a string. And then to get the major, minor, release, and build information that you can specify in version info through the project options, there's this get app versions extended to return a string of all of that information. Here's the code that just goes and gets the high and low out of the file version information from Microsoft. Form create, if it's iOS, OS X, and Android, I don't need that second label to be visible, so I'll hide it. And then for each of the different platforms, when I call the button click event handler, I'll define some local variables if it's iOS and OS X. And then for Windows, we'll just call the function to get the version string and the version string extended and display it. For iOS, I have to get the CF bundle version as a local object and convert that to a string to get the key. And then a few other helper functions to get the version information of the operating system and the application. Same for OS X. For Android, calling the helper function for getting the package info for the package's version name. And we'll run this application. And we get the version information I'm running on Windows 10 here, the app version 1.2 and the app version extended 1.2.3.7. Here in the project options, under version info, I have include version information in the project and auto increment the build number. And so there it is, major, minor, release, and build. If we go and set iOS and go, we've got my iPhone here, we'll compile and run the application. And so we'll hit get version information. It says, oh, I'm running iOS version 14.8.1. I haven't updated my phone to iOS version 15 yet, but I will soon, and the app version 1.0.1. So the second demo I have is an example of using the sensor manager. So here we've got a memo and a second memo, and I've got two buttons, one to find sensors that are available on my computer. Here I'll get the current sensor manager and then make sure that it can be activated. And if it's activated, then I'll go and get all the sensors, see if I have a location sensor to get sensors by category. Then I'll iterate through the sensors that are found. If I find a location sensor, then I'll give it a little bit different display. Otherwise, just output the name of the sensor. And then activate button 2, let's get the sensor location. For Android, there's a little more information you need to provide to ask for permission. You'll need to set a few additional project options. Under project options for iOS, for example, there's a couple additional keys and strings you'll have to specify a string for it to prompt the user to give you permission and tell them why you're wanting to use their location. So you put in strings in these version info for either always use, when in use, or always and when in use. For Android, there's also uses permissions where you specify things like, oh, you want to access location. If we go down under dangerous runtime user approval, coarse and fine location, if you're using that component, T-location sensor. And you set this in the project options, but you also, in the case of Android, need to have some code that will set these options in code. Android versions in the past you didn't need to, but more recent time you have to. You could either write that code yourself, but I love using components. And in Get and also on GitHub, there's a component called T-Mobile Permissions, which is available for design time because you need to be able to set some properties. And then it supports Android 3264. So if we drop this component down, then we can look and just set access coarse, access fine location, and other things, setting those properties of the component. The component will execute as part of your application and make those calls for you. So you get a nice simple interface for setting standard and signature and dangerous, I didn't choose the name, permissions. In the case of my use sensor manager for Android, if we go over to the source code where I'm doing it all in code, instead of using the component itself, I'm going to use that unit that has the code that's part of the component. And if we go up to the top of the uses, I've got an if-def Android for the component, mobile permissions component, the signature, dangerous, and standard units that are part of the package file that I've installed. And then if we go and in the var section, I want to instantiate my mobile permissions in code rather than using the component. So if I go to the form create event handler and I'm on Android, I'll instantiate a mobile permissions component at runtime with its parent to the form. And I'll set the coarse location, fine location, and location extra properties of that component to true, and then call the apply method of mobile permissions, and that will satisfy Android after the user is prompted. One other thing I'll point out is that for Android development, I'd like to do a clean install and remove the previous instance of that application. So I put -clean install in the run parameters. So we'll compile and run this example application on Android. And now the first time, since I said do a clean install, the first time it loads up on my Android tablet, it'll ask me to access the device's location, and I'm going to choose while using the application. And then if I say find sensors, it finds a bunch of different Android sensors of all kinds, motion and orientation and so on. One of those is also the location sensor, so the second button is activated, and I can tap on it and the location sensor starts. As it moves around and the location changes, it will just display latitude and longitude. And that component is available in Get package manager. Just go in and type under components mobile permissions component by Adriano Santos, and you can download and install that in your IDE. We'll go back, choose my target as being my iOS device, and let's go and run it over on the iPhone. So we'll click the Find Sensors, and it found 5 different sensors, 2 motion sensors, 2 orientation sensors, and a location sensor. So now my second button is activated. We can click, and now it says, okay, location sensor started, and we're going to start getting location movement changes. And what is presented to you is through the sensor manager is the old location and the new location in the event handler. And then I should have shown the source code, the location changed. I used the great circle distance algorithm to take the new location and old location and calculate the distance. Now this next demo is one example of what you might do if you don't have a location sensor. There are many different APIs out there for trying to figure out your current location. Here I'm using the REST client component and I'm using the ipapi.com. If you just pass it JSON with no parameters, then it'll get you as close as it can figure out. And then we make the request, get the response back. I use the response dataset adapter to feed the FD mem table. There I've created fields. So here's information that comes back from this IP API. So we can run this on this Windows machine that doesn't have a location sensor. Made the REST request to this ip-api.com, just saying I want it in JSON. That came into the mem table, and from that I can get it's in the US, it's Oregon, Ashland, the zip code, the time zone, who's the ISP. The distance that it found from my location is just a little over a mile. So if you don't have a location sensor and you want to get air quality that's nearby, you might use ipapi.com. There's also other systems that you can use as well. Now, once I got these sensors in a database, I wanted to be able to see where they are, since the sensor is going to return to me its latitude and longitude. So I wrote a little test example that takes one of the sensors' location and then uses the Google Maps geocode API. It's a REST API. And then that'll give us information coming back, and we'll get that into a mem table. In this case, I'm only interested in that big formatted address. There are also JSON for getting the information broken down into number on a street, street name, so on, all these different fields. So the code here was simple. I just pass it the URL to the REST client, including my API key from the INI file. And then I execute the REST request. If it's the status code, if there's an error, then I want to display information with the status text. If it's a good REST call, then I'll just output to the memo that formatted address as a string. And if I get an exception, then I'll just output the exception. So for this latitude and longitude, I get this formatted string. And similar was the getting the elevation. Again, Google, if you pass the latitude and longitude in, elevation API, passing my Google key, and we'll make the REST request. And then what comes back, I've got some fields. I get the elevation, I get the location, and I get the resolution given that location. So let's look at the code behind. Again, I'm just going to call the elevation API, get JSON for the location that's the latitude and longitude. And if it's a good return status, then I'm going to output those fields in the memo. The elevation is in meters, so I'll convert it to feet. Let's run this one. So it says, okay, location was that latitude and longitude for the edit boxes. The elevation, it says 2370 feet, resolution plus or minus 31 feet. Pretty close to what my other apps that I use and my digital weather station says the elevation that I'm at. Now I wanted to be able to have my application have maps, so we wanted to just pass a latitude and longitude and go and map those things. And so I put two web browsers in, called Google Maps, passing latitude and longitude with a zoom factor, and OpenStreetMap, again with latitude and longitude and the zoom factor. And so there we've got, here's the Google view on the left-hand side and the OpenStreetMap. A couple more. I wanted to go back to the database-based applications. And so here is a feed reader. It uses the feeds connection, which is a list in a database of news feeds, a query of that database, and the XML document to parse the RSS feed. So I've got a list box of articles that are found and a list box of feeds, a T-Web browser component for displaying the article that you select from the articles list. So we'll run this application, and then we'll go back and look at the XML parsing of the RSS feed. Right now, my database, as you saw earlier, only has this incident information system web interface, which provides an RSS feed. So when I click on that one, it populates by parsing through the RSS feed and displays postings. These are, it was a pretty bad fire season. You can see all the different wildfire reports that took place, at least in parts of the US that feed into this system. So if we go and click on the Windy Fire entry, then it goes and navigates to the URL that's associated with that article. And inside of that article, HTML, there's the type of incident, so wildfire, how big it is, and most of them are contained now that we're in the November timeframe with lots of rain happening. You could see where these fires were taking place. This one is down near Sequoia National Park. It burnt a bunch of very, very old and large sequoia trees. So let's go and look at the code behind when we click on a feed. The on item click goes in and says, okay, we're going to display the item we clicked on, and then I've got an internal function called get feed items, which is right down here. I pass it the string. I use net HTTP request, and the net HTTP client works across multiple platforms, executing that request to get the feed string. And then I take the feed string that comes back and I load it into the XML document, calling the load from XML method. Make the XML document active, clear the articles list box, and do a begin update. And now we're going to go through and look for a node that's got the text channel, which is part of the RSS specification. The parsing that happened as part of the XML document. We'll find all the different child nodes of each node, in the case of channel node, and I'll iterate through the nodes under channel to find, is there an item? So one of the XML tags is called item. If I'm on an item node, then inside of there's a child value looking for title, looking for pub date. Author is optional, so I've just said I'm not going to care about who the author is. But I do want to get the link so that I can put the URL inside of the list box. And the way I do that is that I create an article list box item whose parent is the article's list box. And then I display in the text property the date and the title of each of the news articles that are found in the feed. Then I put in the detail property, I put its pub date. I put the URL in the tag string, and then I call add object of that list box item to add it to the parent's articles list box. Run through all the articles in the RSS feed and then do an end update. That way it runs real fast in the background, and then the user interface shows up with all the articles inside of it. Okay, 2 more demos to go through. This one is a dashboard. We wanted to have an Android tablet that sits in our family room and we can just glance over at it and see what the air quality is at a sensor, the one that's just up the street, a couple 100 feet higher elevation. And I've got a couple different shared units as well as the main application unit. So let's open up the main application unit. Here I've created a master form and an Android 10-inch tablet form. And I've got a text label here where I'm going to display the AQI. I've got another section of the user interface where I'm going to display an image from an image list for the air quality rating. And then I've got T-chart at the bottom so I can look over time what's happening with the air quality. I've got a spin box up here for setting the number of minutes interval between making REST calls to that Purple Air device to get the latitude, longitude name, get the PM 2.5 value, temperature, pressure, humidity, if I wanted to look at it, and then calculate the AQI. Now, the way the AQI is calculated is this comes from the U.S. Environmental Protection Agency. There's also international standard that this particulate 2.5 concentration. And so there's a setting for how many micrograms per cubic meter of smoke particles. And there's a table that they provide with 6 different ratings: good, moderate, unhealthy for sensitive groups, UFSG, unhealthy, very unhealthy, and hazardous. And the way the AQI gets calculated is by this formula. You can find it online, but here I give it to you in the source code. I populate a table, created a type called PM25 concentration, the AQI rating, the font color, so I could display it in the color that's associated with each of those AQI ratings. And that's a T alpha color. And then these constants that are part of high and low concentrations in AQIs. I found out that if it's greater than 500, it's just beyond hazardous. I populate this array with constant values. So good is going to be green, and these constants that are part of that little table up above. So yellow, orange, because unhealthy for sensitive groups was such a long string, I just truncated it to UFSG. Unhealthy, very unhealthy, and hazardous. Note that anything beyond 500 calculated is just beyond the AQI. So to calculate this, I pass in the PM25 value, and then I return the AQI value calculated from the table, the rating number. You can use that as an index into the image list, the rating string, and the alpha color. Loop through the 6 entries in the table, seeing if it's within the range, and if it is, then I calculate the AQI, get a whole number, so I do rounding of the AQI, and then return the rating index, the rating string, and the color. And then I have a second reusable unit, and this is for the Purple Air devices, and as I start supporting more devices and put the device types in the database, I'll provide additional data modules. So here's the Purple Air REST client. You just call purpleair.com/JSON !show equals and the ID of the sensor that you want. And again, if it's publicly available and people can decide when they purchase it whether they want to give the data to Purple Air to display on their map or not, or if they want it to be a private sensor. And then we will do the request, and what comes back in the JSON that I've created fields for is a whole set of data. I won't go through all of it. You can look at the Purple Air API. The label, the location type, is it inside, outside, the latitude and longitude. There's the current PM value. It also passes the PM values for 5 minutes before, 10 minutes before, and so on. When it was last reported, that's in Unix timestamp. Other information about it, how long it's been up, and so on. And down here, the humidity, temperature in Fahrenheit, and pressure. So first we'll run this application on Windows, and so I hit the start button, and the AQI that's currently happening near my house, it says here the latitude and longitude. This was called top of Terrace Street. That's 2,400 elevation. That's a name string that comes from the sensor. The recent PM25 was 2.99, reported, let's see, about 3 minutes ago. Since it's between 0 and 50, then I display it in green, and somewhere on the internet I found these nice little smileys or crying ones that show up, and I've got those in an image list. I'll take a look at that in a moment. And down here in a T-chart, I just keep plotting lines from the points based on time, and this is running every 10 minutes, but I could use the spin box to, more often or less often. So my Android tablet, it's been running for a little while longer. It's got, 10 minutes, and I've got 10 points. So the last 100 minutes, and again, it's reporting the same current AQI, but I can look back and see that it was above 50, so it was in the yellow or moderate level, and then it's been trending down over time. This is the application that's on this tablet that we keep in our family room on a shelf, and we can just sit there and look at it and watch how it changes over time. And for the image list, I've got a set of icons, and there they are. I found these on the internet at the index offset based on the AQI rating number. We get our good, moderate, unhealthy for sensitive groups, unhealthy, very unhealthy, and hazardous. So finally, putting it all together, I've got my starting mobile application with everything. Here we've got 5 tabs. One is the settings tab, which is populated from the INI file. I've got a status log of information that tells me what's happening in the application, a map for where the sensor is that was selected, a list box of sensors that will show up here, and I can search for the entries in the list box. And then when I select one of those sensors devices, it'll display the AQI and information about the sensor, as well as a chart down at the bottom of that information over time. There's lots of code in here. Let's just look at a few of the highlights. Then I want to look at the deploy information as well. Most of this code there's again the calculation. This one I haven't updated yet to use that shared unit for all these different parts of calculating the API. But I've got 4.7 of 5.5 iOS and also Android tablet and a Windows layout. This is where I put it all together, the calculation of the distance, and I'll be refactoring this and pulling parts out into separate units. Here's the location change, so I want to go and see what the change distance is and update information in the list box, and also then the sensor location where it is on the map, and see what's the distance to the sensor. That way, if I choose the sensor near my house, but I'm driving through town or I'm somewhere else in a way, and I still want to see what the smoke air quality is at my house, or I might choose a different sensor that's closer to where I'm currently at as I'm moving around. We'll display that information and update the user interface for the sensor that's selected. Populating the sensor device list box, I just say select from the sensor devices in the database. If the distance from my favorite location is within the radius, so I've got a spin box that's part of the settings, and I want to order those by distance from my favorite location, which is my house, so I can find the sensor in the list box at the front of the list is the one that's closest to me. And then I'll do that query and then display in the list box information about it in miles and kilometers. Here is the save INI file where I save out. If you change your settings, it'll save the favorite locations and the number of sensors to show and sensor radius and so on. Based on the sensor you choose, they'll display either Google Maps or OpenStreetMap. In this case, I just currently am displaying using OpenStreetMap, but I'll add a setting for which one you want to use, Google Maps or OpenStreetMap, for example, and then that's what'll show up. But right now, the browser gets the URL string from OpenStreetMap. Reading the INI files. If the INI file doesn't exist, then I've got the default values, and then you can go in and change your settings and save back the settings in the INI file. Favorite location, max sensors, it defaults to 20, sensor radius 20 miles, and favorite sensor. And then I'm just putting these on that message tab so we can see what that setting information is. The AQI interval timer, 1 minute. So I multiply that when I set the timer by 60,000, which gives me 60,000 milliseconds, which gives me 60 seconds or 1 minute. And again, if the spin box is changed, then we'll update the number of sensors to show. If the timer's changed, then we'll update the timer for how often to go and make a rest call. A few other things. Here's calculate the AQI, and then a few other bits here and there. Get the AQI for a specific selected device. So if you select from the list box a sensor and so on, and then display the right information and the color. And then I've commented out this code for now. I'm not going to save the data in the database. I may choose to do that at some point in time, but IBLite, the database can only get a certain size. I think it's 100 megabytes. So if I save too much data over time, I might overrun what IBLite's. Let's go back and look at a couple things. First, I want to look at deployment. For my iOS device platform, I've got my icons that are, for launching and for the different bits. And then let's sort this by local name. So then I've got my AQI database, my InterBase database. That's going to start up documents. Here's the INI files also stored in startup documents. And then, you click add feature files or add a specific file. I've already added InterBase to go, and I'm using I have an enterprise edition, so it gives me a IBLite reg key, which is down here, reg IBLite.txt file, which you get as part of an enterprise, or you can purchase an InterBase to go, a license key, and then deploy that with your application. If we go to Android and look, the INI file is going to go into assets internal, and the database also into assets internal when it's deployed over to your device. For Mac OS, it's in contents, resources, startup, and the same thing for the INI and database. And for Windows, since I'm running on my machine, now if I'm going to deploy this to a different Windows machine, then I'll have to copy over, again, deploy the INI file and the IB file. In the startup code, I want to be able to set the database and INI file locations based on the different platforms. If it's iOS, then I'm going to use tpath as part of the IOUtils unit, get the documents path and append the name of the InterBase database, AQI database. That way it'll find it in the right spot based on the deployment settings that you have. And the same for the INI file. For Android, it's going to be in the home path versus the documents path. For Mac OS, it's in the home path. In the case of Windows, I'm running it on my local machine. I just get it from a temp folder, the INI file and the InterBase file. And then I've got an about box where I take that code from the version information and display for the different platforms, whatever the version is, and the operating system. All right, so let's switch over to my iPhone, and we'll start the application. And now in the form create event handler, it has populated from the database all the sensors that are within that radius. Let's go over to the settings tab. So it says here 30 maximum sensors within 10 miles sensor radius. I set the range from 1 to 50 just so you don't end up with a huge list box. I've got over 25,000 sensors in the database now. And I have that favorite sensor in the AQI timer. In the sensors list box, you can also type. So if I want to look at there's top of terrace or anything with Ashland or the first part, and it gives the ID and what its distance is. Oh, it's 0.17. So let's click on a sensor, and then it'll display the name, top of terrace, the current temperature, pressure, humidity. It was last seen in the other example. I was converting it to local time, which is not hard to do. You take the Unix time stamp, convert it to UTC, and then convert it to local time. The sensor's within a mile, so it just says it's basically close by, and then the chart will slowly populate over time. If we go to the map tab, we'll see that same information at the top, and it'll say, okay, there's the map of where that sensor is. And over in the log tab, I'm not moving, so it hasn't changed location, but it just says, okay, we've gotten a couple pieces of data from that sensor after it was started. So let's go and pick a different sensor, like maybe Mountain Meadows. So that's further down in the valley. I'm up higher above, so it looks like, at this time of year, people are burning their fireplaces and putting out smoke. So sometimes the cold air will settle down in the valley and hold that smoke level in. So it's over in the moderate range. Well, that's all the demos for now. Thank you for joining me for this session. Here's some more information that's available. Again, you'll get copies of the slides so you can look for these links, as well as there's the information about the mobile permissions component in Get It and also on GitHub. And with that, it's time for Q&A. Hey, Jim. David I here.
Okay, sorry, I had some issues with my microphone.
I know you're doing lots of stuff with this DelphiCon. It's great. I've been sitting in on sessions, so it's fun to be a participant as well as an attendee.
Yeah, great to have you. Rolf says, David I, great talk as usual. Agreed.
I like programming. It keeps me young, and it keeps me in tune with what's happening in Delphi and C++ Builder and other crazy technologies and devices that I have. This was an example where I could have just kept looking at all these maps and all these other things, and there are other apps that do similar things, but I wanted to build something that I could not only build, but actually use, right, on my phone and my tablet. And again, having a glanceable user interface on my Android tablet to just sit and look or walk by and look and see what's happening. I have a much bigger idea about adding technology and functionality, because there's lots of things that are involved in air quality, including where the fires are. That's why the news feeds, and then getting location data from those, where the wind is blowing. So there's lots of wind-based APIs, because if the wind here in Ashland, when the wind in the summertime, when it's fire season or smoke season, we call it, it's the 5th season now with all this global warming. We get more wind from the southeast, south, and southwest than we do from the north. Usually wintertime, we get it more from the northwest and north. So looking at wind patterns, we can see, and there's predictions that the government does for when that smoke plume is going to get to you, right? It's based on how much wind and what its direction is. And it always ends up in Idaho and Chicago and New York because of the jet stream. So, and the fire, again, the sensors all over the world, the fire could be in the middle of Siberia, but it's going to eventually make it, right, going from west to east as the jet stream goes. So there's lots more to do that way, but and people have asked the slides. I'm leaving it sort of in your hands, Jim, unless you want me to put it somewhere else. I've got a zip file with all the samples except the large one, the AQI Insight, which kind of puts it all together. I've still got some more feature work there, and then I'll get that into if Apple accepts it and Google accepts it, into the stores, and then I'll update some more of the sample source code over time as I finish out some other features. I want to be able to add a feature little star for when you're on sensors. I want to remember that one as a favorite, and then have those show up at the top of the list box for choices. And there's a few other things that I'm still working on as well. Somebody had mentioned about the OSX compiler definition added in Alexandria, so I need to look at that and make sure that I'm more version tolerant of the versions that people might build some of these examples with. And I've tried to do that for the most part, but that was a good catch and suggestion. Somebody asked about why I didn't use Tmaps versus web browser. Part of the web browser is because of the additional capabilities on Windows now for choosing the engine, right? The browser engine, whether it's Edge if available or none or not. So, but I'll take a look at that as well. And there again, there's many different mapping APIs and location APIs and so on. I just chose a couple for the demonstration purposes. Mostly I want to use I'll use the location coming from my phone as I'm driving around or walking around town, and have it, if need be, just pop to a different sensor with another option. We can go through features forever to say, okay, what's the air quality closest to where I'm currently at, right? Right now I got to go and look at the distance in that list box and click on one. So other things to be done.
Yeah, I really liked how when you started out with this, there's a few comments about how you took a simple idea but executed really well. The thing I really liked about it is you're like, hey, this is what I'm trying to solve. Here's a couple, solutions. Here's some things we could use. How do I make this into a program? How do I bring all this stuff together and make something useful? Which I thought you did a really good job with that.
And then as I said, I deconstructed parts of it. Some cases I built test samples to see, how do I do this? And there are so many different options for things to do. Calculating the distance, I think it's the Haver sign, using sines and cosines. There's many different ways to calculate it. Could also just call API and add, walking distance versus flying distance versus whatever distance. There's just, an endless number of those things. Somebody was commenting about the thing over my shoulder. That's a blow up of the original Borland Byte magazine ad, Turbo Pascal. It appeared in November of 1983. I had that in my office at Borland/Cogear/Embarcadero forever, and I have it home. I also have the Borland Way street sign somewhere here in my home office as well, which was the renaming of the street when the campus was built in Scotts Valley, that then became Enterprise Way during the Enterprise time. So yeah, so that
I didn't know that they changed it to Enterprise Way. That's interesting.
Yep. No, to Enterprise Way.
Yeah.
Because Enterprise was integrating the Enterprise,
yep.
right?
Yeah, I remember I visited after, no, I can't remember if I visited the campus before Enterprise. I know I visited after Enterprise, and I saw it was Enterprise Way, but I didn't realize that they had changed it from Borland Way.
Yeah, the sign out front of the campus, the rock sign had Borland etched inside of it. They just put another layer of rock when they etched in Enterprise. But anyway, that's just history stuff. The great thing for me in programming is I can do it anywhere with great tools using Rad Studio. I can show people as well as build my own applications. And I've got, again, lots of devices. I don't have my own air quality sensor. There's plenty of them around me. I do have a digital weather station and a whole bunch of cameras and motion sensors and leak detectors and other things as well that I'm playing with over time, as well as personal medical devices. Yeah.
There's a question here about if the REST APIs you're using, if they cover if they're US only, or if they're international. I'm sure there are international ones, but are the ones you're using, are they international? Or
the Purple Air, I found over 25,000 sensors. I did it brute force. I just would call the API starting with the number 1 and see if I got a return back. And I kept going up to a couple 100,000. And there are sensors in Colombia. There are sensors all over countries in Europe, in Asia. I haven't found any in Antarctica, but in my database, I've got, there's a device type, so Purple Air is what I started with. But there are many other manufacturers, and my plan is to go and sign up for all of those APIs and just keep adding to the database. In the sample database for the source code, I cut it down to be a little bit smaller. I just put in all this Purple Air sensors in that InterBase database that are in Oregon right now. But again, all of you out there, just go into, in the REST debugger, which is the thing. It's just so easy to go in and try an API out and say copy components and paste it in. So you could just go in there and Purple Air, the URL and put in a number. I don't think they have an API search. I'll have to look at that. In the slides, there's the link to Purple Air's documentation, or just put in purpleair.com, API or documentation. There may be a way to search by country or by continent. I just don't remember, because I just said find them all, and I periodically run this background process to to just see if there's any new ones, because people are buying them all the time. They're about $200, maybe $300, but there's, again, I think 10 or 15 different manufacturers that make these kind of sensors that people put in. So
that's great.
There's even more out there, I'm sure.
So Michael's saying, so many great tidbits from your code. Can you recommend a video that shows how to use the iPhone 47 FMX and iPhone 55 FMX stuff?
Well, again, there's probably videos. That's just going into the form designer and pulling down, there's a master view, right? And then you just can pull down and select from the list all of the ones that are pre-populated in the IDE. And then you can go in and change properties that you want specific to, like the width of an input or a different string or things of that kind. So just look for, what is it? I wonder what the feature would be. Form views, is that what it would be? Or
yeah, I think it's form views. It's one of those things that keeps stuffing so much stuff in my head, some of it falls back out.
Ideally, it's, when you're in the form designer, up at the top in the form designer, there's the master view, and then you pull down and it gives you a list of all sorts of other views that you can choose to create. And then it creates these FMX file subsets. It's nice because since there's form inheritance, you can, you can override certain properties, and there's certain properties that you can lock as well, so you can't change them in the subset, or I don't know what to call it, view form underneath.
Yeah, you can't change, for example, the name. You can change the events though, which is really cool. So you can actually have different events for different things, which is not probably as useful, but it is a possibility. A lot of
instantiating a form, you don't have to have a form, right? You can just create a form in code and populate it with everything that you want based on the platform. I did use TOS version dot platform and then to string, right? Converting it to a string, and that works. But I know it's going to be updated because it doesn't handle Windows 11 yet. It says build 22,000 or something like that, which is the sign. But so
Windows 11 was kind of a bit of a surprise. It kind of came at us quick. It's always the tricky thing. So there's a question here. If you already have an app in the App Store, if you could share your Google Play URL so people could check it out.
I don't have the app yet. I need to finish a couple more things before I attempt to get rejected by Apple or Google. There's just a few more features that I want to finish up, and then once I get them into the stores and they get submitted and accepted, then I'll do a blog post on my Embarcadero blog to say, hey, I got accepted, yay, and here they are, for that one. But I've been a member of the developer programs for a long time. I pay my money, and it's getting cheaper. So if I eventually get my apps in there, I won't have to pay as much, because I figure I won't make as much. I'm not doing a 10 million user game or something like that. So, but yes, my blog for when I get accepted by the stores. I haven't tried yet. I just want to finish a few more things so I have a less chance of being embarrassed or rejected, or both.
Yep. All right. Well, we got to go because we have Boyan's session next. But thank you, David, for this, and we'll definitely stay tuned to your blog to find out how things go for you.
Yeah, and everyone, it's great to have you with us, and I miss you all, but you can see me virtually. I'm actually here, still wearing tie-dye. Thanks, Jim. Take care. You're doing a great job.
Oh, thank you. Thank you, David. Take care. Bye, everybody.